this is a quadrant. It is used for measuring the altitude and direction of a star. Kind of like a big turnable giant protractor. This wheel shows altitude. This shows direction. This arm here pivots, and you can sight like that on a star. It pivots there and up there. So this thing can then be turned, and the altitude and direction, or what's called the altitude and azimuth of any star, can be measured to high precision. This degree line here, degree measuring wheel, is marked out with very great precision. Now this is the sextant. The ball lets you aim it and point it in different directions. Again, you see like a big protractor, and then you have different sighting devices along here, and then others here and here. This would allow you to, for example, measure the angle between two different stars. So the other thing, which give you a reading of how far north or south something was, this would probably allow you to make a measurement in between things. I've never used one before, so I've not read a manual on how to use. Nobody uses these instruments for a very, very long time. Here's a small sextant that you can actually mess with, and you can see how you would move it and then sight along it. And then as you sighted, you could read the angle off of the measuring line, or measuring degree, what we call on a protractor, the degrees line. Again, very much like a large protractor. Note that those instruments of Tycho's don't use any lenses. They are what's commonly called naked eye instruments, although it's hardly like he was just sitting there looking up in the sky with his eyes. He was using some pretty sophisticated, highly precision-made instruments to do his observing. But those instruments, in a sense, are kind of like tracking instruments, that where things are in the sky. As by contrast, Galileo has instruments, he has telescopes, and telescopes can bring things in closer to us, let us see things that we can't see with our naked eyes. Brahe simply lets us make precise measurement of what we can see with the naked eye. The telescope, again, lets us see stuff that our eyes cannot see. By the way, I'm doing questions and discussion separately because outside of Tycho's observatory it's windy and the sound's terrible, and inside Tycho's the museum at least, there's people around, and I'd be disturbing him to sit here and talk and answer student questions. Several students asked, in one way or another, why was Galileo such a pain? For example, one person said, why was he so against the idea that the moon causes the tides, and why did he have to be insulting about it? Galileo believed in a very mechanical view of the universe. That was his idea of how things had to work, is that there had to be some sort of mechanical system that operated stuff. Remember his idea that if that the rotation of the sun drove the whole machine, and if you stopped the sun, you stopped the motion of the entire system. Why did he like that? He did not like what he thought of as occult properties, hidden things. he viewed the idea that the moon was having an influence as being sort of like appealing to magic, and old ideas about the moon having powers over water and over women, which we've discussed in class. Why did he have kind of the bad attitude? That's something that historians discuss in some detail. He was really good with a telescope. You know, in many ways, he probably did not have a lot of people around him who could see stuff as well as he could. And you know, he was really smart. He's also trying to kind of fight his way up in society, to sort of be in with the movers and the shakers, when he was a guy from relatively humble origins. Somebody asked, would he have had more success in getting the heliocentric idea accepted by being nicer? Maybe. He might have. But keep in mind that there were some serious objections against the heliocentric theory. Riccioli, it came up, you know, you see in chapter 10, Riccioli came up with some pretty good ones. Riccioli essentially shut down the idea of common motion by saying, hey, the Earth is not all in common motion. Placed different spots on, because the Earth is a rotating sphere, different spots on the Earth are moving at different rates. It's not all moving together. And the specific example was the rock dropped from the top of a high tower, that as the Earth rotates, the top of the tower moves faster than the bottom. So if the rock is dropped, if you go with Buridan's idea of inertia, you know, the rock will keep its motion going, and as it falls to the ground under gravity, it'll be going faster than the bottom of the tower, so it has to deflect toward the east, you know. So there ought to be a detectable effect. There's still the star size problem, you know. So you know, even though he was nicer about, even had he been nicer about it, I should say, you still have to realize there's some serious scientific objections to the heliocentric theory, and then of course there's all the, you know, there's the scriptural type objections, and just the objections that, you know, the kind of the common sense objections, which is, really, are you going to tell me I'm moving 800 miles an hour just to explain the rising and the setting of the sun? You know, so all of those are going to make it a tough sell. In regards to Galileo, a student asked, you know, why did he go through so much to try to prove his ideas, to be under house arrest, and so on and so forth. It's not clear to me that Galileo really ever thought he would end up in house arrest. I think that he probably didn't intend to have that happen, and he just made the wrong people mad, and if he could go back and rewind the clock, he probably wouldn't have gotten himself under house arrest. You know, he's a smart guy, but just because you're a smart guy doesn't necessarily mean you're real good at reading people and you have a lot of good social skills. So, you know, I don't think that he really wanted to end up under arrest for supporting his ideas.
Here's something I didn't know about, and that is that Tycho Brahe's sister was also very much into science and did a variety of different kinds of scientific work. These things are all written in Swedish. I don't know exactly what they are saying. But I believe this is all his sister's writings and works here, or samples of those things. If you saw the film with Tony Christie discussing astronomy and astrology and medicine, you might this might make more sense to you. But this is a diagram of the human body along with various signs of the zodiac, which I imagine have to do with, you know, what thing is involved, what celestial sign is involved in fixing ailments of what part of the body.